In this video, we will see how is done cooling and dehumidification of the air by air conditioners type split with a unit exterior and with one or more several indoor units. We will see how is done cooling and dehumidification of the air inside the indoor unit that mounted on the wall of the building interior. We will see the component parts of the indoor unit, and we will describe the physical phenomena that lead to the cooling and dehumidification. We will see the source of interior humidity, the link between the number of people in the building, and the ratio between energy consumption for cooling and dehumidification. Let's see now how air conditioners type split with a unit exterior and with one or more several indoor units works. The outdoor unit is the one that provides coolant that sends him to the inner unit. In the indoor unit, cooling is happening and dehumidification inner. The people release humidity by breathing and sweating. Also, humidity can be generated in bathrooms and kitchens. The humidity rises with the hot air, enters in the interior unit where it's condensed and also is cooled. More about outdoor units, see the video in the description. For energy auditors or the people interested by energy performance of building, in this video description, you will find a link to a website about energy performance of buildings or a link to a video more detailed about how are made calculations for energy consumption for cooling and dehumidification for energy performance certificate. Let's see now what's happening inside the interior unit. The indoor hot air loaded with water vapor enters in the indoor unit, reaches on the cooling condensing element, where air cooling leads to condensation of water vapor, goes to rotary motor air blower, which returns to 180 degrees the airflow. Additional air cooling by cooling on condensing element, and after that the airflow is exhausted through air swing panel. Let's see more detailed the components of interior unit. We have dust filters, we have cooling and condensing element seen from the front. Also we see the same element from the back, from the wall. Let's see now again what's happening on it. So indoor hot air charged with water vapor enters in the top of this element. After that, it takes the condensation and appears water vapors and appears droplets of water vapor. After that, the cylindrical ventilator rotates with 180 degrees the flow of the air. Again, in the lower part of this element takes again another cooling and cooled air with even more light water vapor. And here are condensed water droplets vapor. Let's see now how the condensation takes place. Condensation of water vapor from the indoor air, which results in dehumidification. Indoor hot air loaded with water vapor enters to a cooled element. It takes condensation. The energy from the condensation is taken from this element from coolant from outdoor unit. It takes to outdoor unit to recharge and cool again this element, and cooled air with less water vapors goes outside. What does the phenomenon of water vapor condensation mean? When we take out a bottle of cold water from the refrigerator, on its surface appear drops water vapor condensation from the air. Dew point. What does it mean? Dew points is the temperature from which condensation begins, vapor condensation of water in the air. It depends on interior temperature of the air, and also it depends on relative humidity of the air. More about condensation, see the video in the descriptions. Sources of humidity for a house are breathing and sweating, approximately 60%, which means 56 grams on hour per person. Bathroom, 22%, which means 22 grams on hour and person. And kitchen, 18%, which means 18 grams on hour and person. The total 100% is 96 grams on hour and person. The amount of condensed water from vapor is proportional to the number of people in the cooled area. This is the water vapor, condensed water vapor from the outside of the building. That means if we double the number of people in the house, we'll double the amount of condensed water from vapor. Proportions of energy consumptions between cooling and dehumidification. It varies between 19 and 10% to 60 to 40%. The proportions vary depending on type of building, if it is residential or non-residential, the degree of shading of the building. The more shaded the building is, the higher the proportion for dehumidification.